Okay, so Ohm's law, we said that basically voltage is directly proportional to the current, so more voltage, more current. But resistance resists what? Well, resists the current. It limits the amount of current that'll actually flow through something. So those are inversely proportional. So more resistance, less current, right? Okay, so let's try an example with this. Let's say, get my face out of the way. Um, let's say we have a battery, and this is a symbol for a battery, and we'll talk about the schematics and the symbols a little bit later. Let's say we have a battery that is providing 3 volts, and we have a resistor that we know is 6 ohms. I want to know how much current is going to go through that circuit, right? Well, I equals V over R. Current is voltage over resistance. So we said 3 volts, 6 ohms. Ohms uses the Greek letter for O, ohm symbol. The omega, thank you, Greek letter omega. And I would be 1/2 of an amp. And here's where we gotta get used to all the lingo. If we're dealing with voltage, volts, V, that kind of makes sense. Current, we're dealing in amps, and that usually has a little symbol A, and the variable is I, and resistance measured in ohms and has a little omega symbol just like that. All right, let's try another one. Let's say, again, simple circuit. I actually don't know how much resistance that is, but now I know that I'm getting 2 amps of current out of it over a 6 volt source. So I want to know what is the resistance of that resistor, that light bulb, that toaster, whatever it is. Well, I want resistance. I'm starting with I equals V over R. I want to rearrange this. If I multiply R by both sides, I get V equals IR, which is useful if you want to find voltage. But I don't want to find that. I want to find resistance. So I'll divide by current. Say R equals V over I. Okay. I got 6 volts over 2 amps. That gives me resistance of 3 ohms. There we go.